I see it now starting. Yeah.
Okay.
So in the following 15-20 minutes, Martina will talk about how to deploy Frost in Docker. Then Beatrice will describe examples of data ingestions in Ferrara sourced by different types of APIs. So from proprietary and heterogeneous APIs into the Frost instance of the municipality. And then we will have the discussion about semantics. Okay, I leave the floor to you, Martina, please.
Okay. Hi, everyone. I share my screen and start the presentation. So I will talk about the deployment of Frost with Docker. Here you can find all the information and from the official site, and is that we will see in my presentation. So you can run Frost server inside multiple Docker containers. So you need to have Docker and also Docker Compose. The step you have to do are to download the Docker Compose file, start the server with the Docker Compose app command, and then you could insert some demo entities. So what is Docker? Docker is an open platform for developing a running application in an isolated environment called container. The container are defined using image. So the images are template with the instruction for create the container. An image are described in a Docker file. A Docker file is a test document with all the command for the image. So you can write your own image, or you can download from a repository with the command docker pull and the name of the image. The container is a running instance of an image. It's very easy to create, start, and stop a container. The container are like a small virtual machine, but more light. And in a virtual machine, you can have more container running. Docker Compose. Docker Compose is a tool for defining multi-container application. Is a file, a YML file, where you can configure your application services. So in the file, you can have more services. In this case, this is the Docker Compose file of the Frost server. You see we have two services, web services and the database services. And all the image, all the parameter needed to for those services. The first step you have to do is to download the file. For this session, I download the file in my computer. So I have a Windows. I have installed Docker Desktop, and I download the file in my computer. Then you start the server using the command docker compose app. You wait a few minutes, maybe less than 5 minutes. After the command, you will see you will have two images and one multi-container. A Frost server is running. So we can see now in my, this is the Docker Desktop. Could you see my Docker Desktop?
Yeah.
Yes.
Yes. Yes.
You see that there are two images. the Frost server and the PostGIS server. This one is the default that you have when you install the Docker desktop. There is also a multi-container. That one, the Frost, is a multi-container because it contains, as I said before, two applications, the web application and the PostgreSQL with PostGIS extension database. The last step is to, I can also open the browser and see. This is the server running on my local computer. We can also do this together. So the first thing is to clean what already have. The first thing is to stop the container and delete. Okay. So it's very easy to clean what you have installed and to do it again. Then I clean also the images, delete forever. Delete also the image. So this is a clean Docker desktop installation. I open the folder where I've downloaded the Docker Compose YML file that we can open with Notepad. Is a text file where you can apply your you can modify this file. Maybe you can change the password, change the port, or whatever you need to change. Then you can go in the you can open a prompt. Open a prompt. I go to the folder and I run the command docker compose app. It starts to download, to pull the image from the repository, from the Docker Hub. As you can see, there are two services, a database and a web. You can see that they are composed by more layer. After when everything is, it has been downloaded. We wait because it's interesting to see that it's. I think it's very easy to do this. Also to answer to the question of that has done before the Black Alessandro. So the download has finished. Now it is starting the database and the web server. So we have to wait only few seconds, I think so. Okay. I go back to the Docker desktop and you can see that I have the images that I have deleted. I have also the Frost multi-container that is stopped. So if I go there now, maybe I have to, sorry, that is running. So it's again working. And I can show you that is, maybe I have to close because I have in cache the things. Or maybe they have already in the database, because there is another step to insert demo entities you can download the demo entities and then post it to the server. I try to close because I'm not sure that is in cache or not. So I open again. Okay, is running. If I stop only to show, it's not finished too. Sorry, I have been too fast. So now I stop the server. So you can see that there is nothing running. I look for something, but you see that there is nothing. Now I start the server. I refresh. You see that the Frost is running. And I have no location, or the database is empty. Now I can I show you how to add the demo entities that I've already downloaded from the Fraunhofer server. So in the folder I have the demo entities. That is a JSON. With this command, I can load into the server. Okay. Now, if I refresh, I can see some location, things, and whatever, some observation. Okay. I think that it's very fast with Docker to have a first installation of the server running and with some data.
Okay, thanks.
Okay,
Thanks, Martina.
I finish my fast presentation.
Thanks, Martina, for this very, very fast presentation about the second type of deployment of Frost in Docker. I would leave comments or questions for the end of this part. So we may leave the floor to Beatrice to go back to Ferrara, in particular for looking how we managed, how we are managing the harvesting, the ingestion of data that are provided by different sources, as Luca mentioned at the end of the first part. These data are related to different domains, and Beatrice will present different types of APIs that are used for ingesting data, so that are connected through Apache NiFi to ingest data into Frost instance. Beatrice, the floor is yours.
Yeah, I'm sorry, I will switch off the camera because my connection is not super good, so just in case.
Okay.
But can you hear me well?
Sure, yeah.
Okay.
Yeah.
Okay, so I'm going to talk about how do we actually ingest the data in Frost, and we do that using Apache NiFi. So let's start. Okay, so what we do usually is we create an ETL flow that, for those of you who are not familiar with the word ETL, basically it stands for extract, transform, and load. So what we do are exactly 3 actions. We start with extracting the data, so retrieving them from the API or like any source that where the data are. And then once we have them, we can proceed to transfer them, which means basically this is like the hardest part. Usually we take the data like as they get out to the API, and we transform them so that they are Frost compliant, so they can be put in a Frost structure. And finally, we load them. So in the Frost server, as was described before, we have as we have it, we can download the data, upload the data inside the tables. How we do that? I already said it with Apache NiFi. NiFi is a tool that was built by the Apache Software Foundation. It is flow-based, which means that you can actually choose different processors, so these white boxes. You choose the one with the task you need, and you put them together, creating a flow. I will talk today about one example in particular, which is the Mistral project. Mistral was a EU finance project which started in 2018, and it's now over. It's about meteorological data, and the main goal of Mistral was to build a portal to reuse the data set related to meteorological data. The main output is this platform where, as you can see, you can choose the variables that you need. So, for instance, temperature, the time range, you can fix some parameters. And after doing that, you can get the data. You can either choose to visualize them on the map, or if you push the orange button, you can download them. But still, I mean, this is really nice to do, and you can get the data you need in a particular time frame. But what we wanted to do was, I mean, this was not our objective. We wanted to take data which were up to date in an automated way and continued way. So we could not actually go every day, like wake up every morning and go there and push the button and download the data. So what we did was we used the Mistral API. So basically we connect to the API, and then thanks to NiFi, we can build a flow that retrieves the data daily or like every hour as we need. Okay, let's say now we have a way to retrieve the data. How do we make them STA compliant so that we can put them in the Frost structure? Well, we do so by first mapping the data. So mapping means that we have to associate a STA entity to a Mistral entity. So STA entity, I think you have them clear. They are like the things, the location, the sensors, and so on. So they are the entity of the data structure of SensorThings API. What we need to do before even trying to do something is to decide what we associate with every entity. So for instance, what is our things? What are our observations, and so on. So in the case of Mistral, for instance, we decided that the thing is the station of the station that measures the observed properties. And then we had to choose what were the observed properties that we needed. So for instance, temperature, wind direction, wind intensity, and so on. And after we have done this mapping, we can actually perform the transformation. The transformation is what basically brings the data from being the JSON that goes out of the API to being the data inside the Frost tables. And finally, once we have done this, we can actually load the, upload the data inside the Frost structures. So like the output of this ETL process would be, we will have tables that are like the Frost tables with data inside. But let's since now I've been a bit theoretical, but now I want to show you exactly how a NiFi flow works. For the sake of these examples, I created this flow, which is a bit like a simplified version of the actual one, but there are all the main tasks that are needed. So just before starting, I want to give you two words. The first one is processor. So the white boxes that I was talking before are called processors. Every processor has one task. So you can use it like basically depending on what you want to do, you will choose a processor and you will put it in the flow and link it to other processors. And the other word is flow file. So every time you start a flow, every time you start the flow, a flow file is created. And a flow file is basically a file that goes from one processor to the other throughout the flow. The flow file is important because it brings information. So it is the way how one processor sends the informations to the next one. It can contain data and metadata. And also, for the sake of this example, we will say that every time we start the processor, we will have one flow trip, and one flow trip will be 1 day of data retrieved, transformed, and loaded. So you have to imagine, like, when you start the processor, one flow file is created, and when the flow file is ends the flow, then we will have 1 day of data inside our database. Okay, let's see how the processors work. We first have a generate flow file processor, which is the initial processor, and all the flows start with this one. Basically, it's the one that creates the flow file, and we can like put some information that are then put inside the flow file. For instance, what we decided to do was to put inside the flow file the first day we wanted to download. So for instance, we say, okay, we want to download the first data from the 1st of January, 2023. And so we put this information inside the flow file. Okay, now the flow file, let's say the flow file does its work, it goes throughout the flow, and it downloads the first day of data. So now we will have all the data that we need from the 1st of January. What happens the second time? Like I said before, the flow file is the one that brings information, but then how does it happen that the second time that we start the flow file, how does the new flow file work, knows that it needs to download the 2nd of January? To do so, we use a support table, so a log table. Basically, NiFi is linked to the database, and we can create tables there to keep track of what's happening. We did that and we created a log table. So as you can see, we used the batching. So every time there is one flow trip, and basically every time a flow file is created, we create a new batch inside the log table. We know when is the start date of the data retrieved, when is the stop date. We know when the API is executed and when the data are ingested. So we know exactly what's happening, even if we don't keep checking the flow. Okay, so how do we connect actually connect the flow and the table? So we have this processor which goes to the table and checks what is the last date of data. For instance, here it says, okay, the data are retrieved until the 1st of January at 11:59. So basically checking this, the flow can now create a new batch inside the log table, and say the data that will now be downloaded will be of the 2nd of July, since midnight until 11:59 p.m. Okay, so this is the first part. This is how we deal with the keeping track of data. Let's see now. Well, this is where the real things happens. So the API call. So now that we have all the information we need about the data to download, we can actually download the data. We do it through the API with this processor. The information we need to give to it is the endpoint, the start date and the stop date. So basically the time frame of the data we need, and the variable that we want to measure. So the observed properties that we are interested in. And the answer of the API call is, in this case, a JSON, which is like a bit of a messy JSON. I mean, not messy, but it contains a lot of information that we might not be interested in, but it's still like the information that we need. And since we want to keep track of everything, we can now go to the log table and add an API execution timestamp, so that if we go back later on the table, we know exactly at what time the API did the call. Okay, just 1 second. I want to explain this because, of course, like we wish that the flow always goes right, but sometimes, unfortunately, it goes wrong. So how do we deal with errors? Well, we do this using processors that communicate directly with another support table in the database, which is the error table. So together with the log table, we have an error table where every time an error occurs, we go and write the timestamp and the type of error, so that if tomorrow I wake up and I didn't check the flow file for the whole night, I can check if some errors occurred. Okay, but let's say we don't have any error and the API call goes well. Now I have my JSON, which I was telling you before. It's a bit messy, or better say it's full of data that maybe we are not interested in. How do we actually go from that JSON to our Frost data? So let's go into the transformation phase. There are many ways to do this, but I will show you how we did this inside this flow. So first, we used a script. So in NiFi, you can, of course, insert script from different languages. In this case, I used Jython, which is Python, but written in Java. So with Jython, I took the information out of the JSON, only the information we needed, and so I cleaned the JSON, and I created a new one, which was basically only contained the information we needed. So as you can see here in the flow, a nested JSON enters, and which is our flow file, and then the flow file that goes out contains the new JSON. Okay, so now that we have this, we can. I used another, like we used another way that might not be the more elegant, but this is for sure one of the simplest, I think. We used a support data table where we temporarily put the data so that it's easier for us to work on them. So once we have all the data we need, we put them inside this table, which is inside the database. Why do I say it's easier? Because like once we have the data inside the database, we can use SQL queries to move them from that temporary table to all the Frost tables. So once it's in the database, it's easier to move them. Okay, so basically what happens now is exactly what I said. We have this group of processors where each one of them like puts data, for instance, from the temporary table to the location table, from the temporary table to the things table. So basically we go populating the Frost tables one by one. And here you see that this processor is a bit bigger and grayer, and this is because it's actually a group. So I grouped different processor, which is a thing that you can do in NiFi. Okay, so if everything goes well, then we for sure go to the log table and we put the ingestion timestamp, so we know that everything went well and there was no error. And finally, we can delete data from the temporary table so that our database is clean and it only contains the data that we need. Okay, so this was one flow. And like at the end of the flow, then we can start with another flow file that does it again. The good thing about NiFi is that you can schedule it. So you don't have to every time start the flow, but the flow can be automated and you will download 1 day of data every day at the time you need. And then thanks to it, you will have historical data in your database, which are for sure ingested as a Frost in a Frost structure. Just to conclude, I want to show you 2 other examples because, yeah, I talked about meteorological data, which maybe are not so much related to what we are doing in EDIAQI. Also, this example is not much related, but it's a good example of what we did. We did basically the same with these road traffic data, which are publicly available in basically Emilia-Romagna region website, and like the API is also public. So we did the same. We took data from the API, we made them STA compliant, and we put them inside the database. Well, this example, I think, is way more related. It's outdoor air quality data. I already showed you this, I think, last time. These are the stations which were installed by Lab Service Analytica in Ferrara. And we did the same. So we used NiFi to retrieve the data from the Lab Service API. And then we transformed them and we put them in our Frost structure. And finally, thanks to that, we could build dashboards and this nice visualization. So that's all from my side, and thank you for listening.
Thanks once again, Beatrice. I don't know if now are there any comments or questions from the audience regarding both the deployment using Docker or the ingestion just described by Beatrice. Raniero, please.
Hi, Raniero here. I would like to ask, during the demo, I tried to set up the Docker, and that's kind of straightforward. I'm on Linux and try to set up Apache NiFi as well, and I kind of get to the point where it's installed, and essentially I got login, asking me for user and password, but I haven't found a way in the config, or I missed the line where this user and password are set. Essentially, I got a browser page to access NiFi, and I don't know if it's the time to do this, but
maybe this is a question to Martina. I don't know if if we have time. Enough.
But the question is regarding NiFi or Frost?
NiFi.
Oh, sorry. Yeah, Beatrice, and sorry.
Yeah, actually, I didn't. I use NiFi, but I didn't put it into our system, so I don't know. But yeah, I think we should definitely find an answer to this question because, like, I think a lot of people will need this.
So,
I haven't Googled it, so it's probably maybe easier than.
Yeah, exactly. But I think we can go back to this, like maybe ask our developers.
Yeah, and we will put also in the brief document that we were thinking and discussing during the first part, containing some possible tips and tricks.
That would be great, so everyone can kind of try to deploy and see how it works.
Okay.
Thanks.
Okay, I take the opportunity to ask to Hylke, but also to Michael from Michael from Wings, if they already had worked with Apache NiFi for managing ingestion flows.
I've not used Apache NiFi yet. No, that's new to me. Looks interesting.
Okay.
When you importing that, are you then inserting the data in Frost through the SensorThings API, or are you doing it directly into the database?
Yes, also I've never worked with Apache NiFi. But
Okay.
It's interesting.
Yeah, I think that the question by Hylke is for you, is to you.
Yeah, I'm sorry, I didn't hear it.
When you insert the data into Frost, are you doing it through the SensorThings API, or are you inserting them directly into the database?
We are inserting them directly, like we are doing simple queries, database queries.
Yeah, okay, that's if you do it that way, then you won't get notified on the MQTT endpoint that there is new data, of course. But
okay.
because Frost doesn't know there's new data because it's directly in the database.
Okay. Well, thanks for saying that.
Okay, we may skip to the next and final presentation that will deal with the semantics. This is a very short presentation that is a sort of prologue of an open discussion that we would like to start today. Actually, we already at least partially started to discuss about the need for defining a common semantics among the different pilots we have in EDIAQI, as well as with the no center that is in charge for the data platform. So I'm sharing my screen. Here we are. Could you please confirm that you can see my screen?
Yes.
Okay. So very briefly, in here we are providing a very first and rough proposal of possible parameters and unit of measures that might be important to have for pilot areas in the EDIAQI project. So dealing with indoor air quality, but also with the outdoor air quality, of course, if these data are available. So if the sensors behind are collecting this type of parameters. So this is a list, of course, strictly related and focused on a specific pilot, on the specific pilot of Ferrara. Again, let me highlight that this is just our own proposal, just to break the ice. In here we have 1, 2, 3, 4, 5, 6, 7, 8 parameters for air quality with a corresponding possible unit of measure, micrograms for almost all parameters. While here we put climate-related parameters to be considered. So temperature, relative humidity, air pressure, with the corresponding unit of measure. So the first question that I have in particular for lab service Analytica, for Wings, and also for THINNECT, even though I haven't seen anyone from THINNECT connected today, is about this list of parameters. If you have any other parameters that we need to consider. Of course, among different pilots, not all parameters will be collected, but it is important to have a common list of parameters in order to avoid overlappings and gaps. And of course, when talking about parameters, we are also need to consider unit of measures. So the first question to to be replied after this presentation is about the completeness of this initial list of parameters, and if you see any gaps, any lacks, any parameters missing here, we may, after the final slide, we may add them directly into these slides. Of course, we also need to consider the frequency of data that we need to share among pilots and the central data platform. I remind that the idea behind the EDIAQI project, and in doing this, I'm asking confirmation also to Mario Rovrich and also to colleagues from No Center. The idea is to have a central data platform for performing data analytics, deployed and managed by No Center, collecting data from different pilot areas, from different partners in charge of pilots. And so we need to define also which are the requirements for the frequency. Here we put just as a simple hypothesis a frequency of data of 15 minutes. But if you think that for specific use cases we need raw data, so single measurements, or more aggregated, temporal aggregated data, so I don't know, half an hour or hourly data, we need to again to amend this table by adding the possible other frequencies of data. We may have more frequencies of data. We may consider also the possibility to provide and share both raw data, so every single measurement, or values that are aggregated, temporally aggregated every X minutes. This in this case, we put a possible frequency of 15 minutes for both the list of air quality parameters and also for the climate ones. More important is the values that we want to consider. So if we aggregate data at 15 minutes or at 20 minutes or 30 or 60 minutes, I think that we need to consider the let's say the which values do we want. And again, here we put a possible first proposal for having at 15 minutes frequency, not only the average value, but also minimum values, maximum, median, and standard deviation values. Again, for all the parameters listed for air quality and also for climate related. Again, for these two tables regarding the proposed values and also for these ones related to the frequency, I would like to leave the floor to Alessandro and to Michael after this presentation to better understand their point of view from the perspective of pilots and from the perspective of partners of the EDIAQI project working at pilot level, but also from Mario and from other colleagues of No Center related to possible use cases and requirements related to the No data platform. Okay, the last part of the discussion that we would like to start with you in a while is related to how to deal with spatial location. Spatial location is, as written here, is where stations, in this case, in the case of EDIAQI, where air quality monitoring stations are installed, are placed within pilot buildings. So in different rooms, sometimes at different levels, different floors. And the spatial location could be either expressed as simple points, that is our main proposal, but for specific use cases, there could be a place also for providing information about location as polygons. Here we have some examples. So when considering not the location in terms of SensorThings concept, but in terms of how to have geographical references, pilot buildings could be expressed like this, so like points. Here is we have one of the pilot buildings identified in Ferrara. It is a high school named Copernico Carpegiani, and in this case, the building itself is simply represented by 2 coordinates, lat long, describing a point. But the same building could be like this, could be a polygon or multi-polygon with an array of coordinates for one couple of coordinates for each vertex. So the same 2 concepts, point representation or polygon representation, could be applied to location when referring to stations in the framework of EDIAQI project. Again, in this case, zooming in within the same pilot building of the Istituto Copernico Carpegiani, we may have different, we will have different stations that will be installed by lab service in different schoolrooms and different laboratories in one library and so on. So each location representing where the station will be installed could be geographically represented as points, 1 point for each station, like in this way. But of course, we need also to better manage cases where different installations, different stations will be placed in different levels and different floors of the building. That's why we may think of having specific properties, like in this example that is not taken from SensorThings response JSON, but it is an example just for highlighting the fact that apart from the coordinates, we may have different properties related to each station. For instance, an ID for naming the specific room. So let's say room number 1, room number 2, and so on. And also the floor, the level 1, level 0, level -1, and so on. The geographical dimension, the geographical properties of the stations could be either represented as points or as polygons. So I think that it is up to each specific pilot to decide whether to consider the geographical representation as a simple points or as a more complex polygons. We will have in the following and final 2 slides 2 real examples of locations as JSON provided by SensorThings response. One related to the example of location expressed by simple points, and the other one by polygons. I think that the decision could be undertaken by each pilot depending on the specific requirements that we have. So the first case is this one is taken from the SensorThings API endpoint of the municipality of Ferrara, where all locations are expressed by points. So like in this case, we have the coordinates, so the points representing one of the air quality stations of the Emilia-Romagna region. And here we have the lat-long coordinates, the name of the station, and in this case also, as mentioned by Luca in the first part of this session, a specific property that we define for distinguishing different sources that we named organizations. So this is a first example, but a second one is coming from the Fraunhofer Institute. So it is something that could be eventually better explained also by Hylke, that is still connected, I guess. In this case, we have locations expressed by polygons. Okay, we can see here the type of location is polygon, while here the type of location was point. And polygon means that here we have a list of different vertices, in this case 9 points, 9 vertices representing an administrative statistical unit. This example, of course, is not referring to the image on the right, but is referred to this endpoint where the Fraunhofer Institute is providing time series of demographic statistics using as a typology of location, not single and simple points, but polygons representing such statistical units. Okay. Last slide is just for reminding that when considering both points or polygons, we may have, we should have at least 5 or 6 digits as decimal in the coordinates, like in these real examples here. Well, in this case, we have more than 6. We have 8 digits. That means that the precision of that specific point is quite high. But to distinguish between different locations representing different indoor air quality stations installed or to be installed in different rooms of the same building, it will be sufficient to have 5 or 6 decimal digits for both for both latitude and longitude. Okay, so going back, we need now to open the discussion with Know Center, Wings, and Lab Service. Unfortunately, THINNECT is not connected, and start understanding if we may have this initial list, this list as initial list of possible parameters to be considered as a common parameters among us, among the project consortium for better manage indoor air quality data, but also other data related to other phenomena like climate-related data. So I leave the floor. I would like to start discussing with you guys. this is also reflected in this final presentation that Beatrice prepared.
Yeah,
So,
I can share it.
Yeah. So, what do you think about the semantics that we proposed? This is an initial proposal. Alessandro, Mario, or Mikhail, who breaks the ice?
I was waiting for the intervention of someone else with respect to me, but I will start again as first, hoping that everyone agrees with what I'm saying. So, for my point of view, from my side, I can say that what you show in the last slide is something we can agree with. So to have temperature, humidity, and pressure expressing in Celsius degree, percentage, and hectopascal, and for particle and gases, an unit of measure in microgram per cubic meter, with an exception of the CO that from local authorities to the research activities or entity are used to express in milligram per cubic meter. So my suggestion is to continue with the unit of measure you highlighted in the last slides. For what concerns frequency, also looking at what Hylke said, I agree with him with what he said. We have raw data express with a frequency of 5 seconds. Is a too much high temporal resolution from my side. It could be interesting from a research point of view. So it could be loaded on IPCAM portal or in other database for a research point of view. But if we need to show or to deal with the data, I guess that time series express in 10 minutes or 1 hour better could be fine. Also because when we look at the main guidelines on indoor air quality coming from WHO or local entities in charge for health, we are used to see suggested limits expressed per hour. So a time series expressed with a frequency of 1 hour per each point is enough. But we can go deep in, so we could have also a time series expressed in 10 minutes.
Okay, Mikhail, well, I don't see Teams interface, so I don't see if Mikhail is connected. Yeah, okay.
I'm here.
I guess. Okay.
Okay, the parameters for indoor devices are okay. Also, the frequency of 15 minutes, I think it's also okay. That's all.
Okay. So do you see any needs for sharing data at a different frequency? In particular, do you see any needs, of course, common needs for sharing single measurements?
No, I don't think that sending data on a lower frequency is necessary.
Okay.
Maybe at 10 minutes, the lowest.
Do like this, then of course we will have time to, oops, what is it? We'll have time for tuning and for finalizing this decision. Mario or others from No Center, which is your idea, your feedback about parameters, unit of measures, frequency, and values.
Okay, so then I talk. I'm not really sure how I can connect like how the data platform is concerned with the frequency and all these certain parameters, and so I kind of struggle with like giving my expertise in that regard, if it's like good or not.
Okay. And I don't see. I don't know if Mario is still connected, because I don't see the list of participants now. If someone could help me in understanding if Mario is here, is in. Yeah, I think could be interesting to have his own contribution, his own perspective.
I think he was participating, but he's no more participating now, judging from the list.
Okay. So we will have a second round with maybe with Mario and also with Jurgo and or others from THINNECT in the following weeks and months. Regarding location, our own suggestion is, of course, to make it as simple as possible. So to think of possible expression of locations with simple points. So one point will correspond to one station. Of course, there will be probably a one-to-one relation between station and rooms inside of the pilot building. So the location could be managed in SensorThings like the example here, with a simple point as a type, a name maybe could correspond to the name of the room where the station is installed, and here in the properties, attribute that we might customize, we might have a property called, for instance, level to manage the information about the floor. At least for the initial moments, we warmly suggest avoiding more complex types of geographical representations like polygons. Okay. I don't know if Hylke is still here and if he has or not some suggestions, yeah, regarding in particular polygons.
One interesting thing you could do is have the polygon in the location of the thing, but use a point for the feature of interest. Then you can both see, then you both have extra information of about your building or your room, but you can also still see exactly where in your room your sensor is located.
Okay.
Just an idea.
So the room, the polygon. Oh, sorry, Martina.
I have a question because I would have done the point in the location and the polygon in the feature of interest. Why do you suggest? There is some reason why do you suggest to put the polygon in the location and the points in the feature of interest?
That's a good question. Generally, when I look at the SensorThings data model, I usually see the thing as being the object that you're interested in. But both views are possible. The feature of interest is usually or is often the sample that was taken to make the measurement. Of course, in this domain, you're not really looking at sampling, but in my mind, that split is still there. So the features of interest is more the approximation of where the sensor is, and the location and the thing are the more detailed or the real world thing. Like if you have a car that's moving, you'll probably have points on both sides, but the feature of interest, of course, every time a new point. Whereas if yeah, but yeah, both options are actually valid. So
okay, thanks Hylke. So I think that we will finalize this decision about how to manage a common set of structures for sharing data through SensorThings APIs between data platform and pilots in the following months, maybe during the project meeting that we will have in Dubrovnik in mid-September. There will be the possibility to better discuss some specific details and take a final decision. Okay, I then would like to ask the second question to the partners representing pilots, but also to Know Center. Basically, what is the schedule and timing for deploying SensorThings APIs at both a pilot level and project level? Maybe starting with Alessandro, that already explained that from the point of view of lab service, they are already somehow using a SensorThings API based on the server infrastructure of the municipality of Ferrara. So the very first idea could be to reuse such server, but in the medium term, which are your ideas for deploying on your own premises SensorThings API solution, maybe hopefully based on Frost.
Okay, you already explained what we are doing, and yes, as I mentioned at the beginning of the call of the webinar of today, yes, our willing is to have Frost server on our premises soon. We have not defined yet the timing for implementing it. Not because we don't want to do that yet. Yes, of course, but because at this point in time we are guests of the server in Ferrara, where we have also the air brake data for the outdoor air that will be used as a reference for a comparison with the indoor air. But yes, as I mentioned, my the question during this morning call are were focused on cost and time, so efforts for implementing it, because my personal point of view is that we are facing an activity that is useful for the project and for all of us, because we are talking about an ISO standard. So it is important to implement it in the project, and I am giving you a personal forecast on Frost server implementation. I guess that in Q4 of this year we will start.
Okay, thank you very much, Alessandro. Clear. Regarding wings, Michael, which are your possible timing for deploying SensorThings API for your situation? I think that Michael disconnected.
I'm here.
Oh, no, okay, sorry, okay.
So just ask again, please.
Yeah, which are your timing? Which scheduling are you planning for deploying a SensorThings API compliant solution in your own premises for the pilot you're in charge for?
From September.
Okay.
We will stop working for August. And from September, I will deploy.
Okay. Okay. Good. And David or Lawrence, regarding the Know Center, have you already started to work on Frost? Is it right?
Yes. So we try to do the synchronization, because we are planning on the central Frost server.
Yeah.
And so that we can synchronize with the other Frost servers, or update it also via the MQTT protocol. And that worked out, but we're prioritizing also to include the Frost server in the data platform. But I can't say a specific date right now, but I would also assume in the next month.
Okay. Yeah. Okay, thanks. Good. So I think that this is quite in line with the overall scheduling of the project, because as we remind in mid-September, from 18 to 22 of September, we will meet in Dubrovnik for the next project meeting. And I think that in there we we'll have hopefully the possibility and time to better discuss about these details regarding semantics and related issues, but also about the timing for deploying SensorThings endpoints, possibly based on Frost in the different premises. And therefore, the next training session within task 4.3 could be planned the day after the project meeting in Dubrovnik. So what we would like to anticipate to you is this proposal for having a third training session to be scheduled on September 28th. It will be a Friday, again in the mornings, in the morning. And the next session will be focused on clients for accessing SensorThings endpoints. Today also with the presentation of Hylke, we had some initial examples. During the third session, we would like to go in details talking about which tools, which libraries are already existing out there for being reused, already able to connect to SensorThings endpoints, and we will see some existing and running examples, some of them related to air quality. For the desktop, we will have an in-depth demo of the QGIS plugin that we developed last year for enhancing QGIS, that is a GIS software widely used to be able to access dynamic data from SensorThings APIs. So to conclude this session, we will circulate in the following weeks an email with a fixed proposal for this date, hoping that the majority of us will be available in that date. I remind you that also this session is being recorded, and with the slides that we prepared, also the videos will be made available in the project website. If there are any other comments, I can stop the sharing of my screen. Okay. And we may stop the recording of the video. And again, if there aren't any comments or questions, we can